Good evening, guys. My name is Stefan Fischer. I'm the CFI at Henley Air. We are getting ready for a night shift, and it seems to be a beautiful evening in Johannesburg. While you guys are all in lockdown, I hope you are getting to your studies. The school will be posting videos and tutorials on questions that students have problems with in general. So keep an eye on this channel. Okay guys, so here we are. Our first tutorial will be about altimetry. Let's have a look. The first question is, why do we need to understand altimetry? And the short answer is safety. First of all, you understand and you can work out ground separation between yourself and obstacles, and then also aircraft separation. The need in application is to understand quite a few things. Altimetry is used in air law, meteorology, and then also it ties up very nicely with the semicircular rule. So the first golden rule is to draw a very simple picture with the sea level down at the bottom, ground level, and then your little aircraft that is flying somewhere at the top. To determine your altitude above sea level, you have to understand that QNH altimeter is always measuring from sea level, and that changes from day to day according to the weather patterns. In this example, if you are flying at an altitude of 6,000 feet, it means that what you're seeing on your altimeter is a reading from where you are all the way down to sea level. If you know the area where you're flying at, for example Johannesburg, you will see I've marked a few spot heights. There's 5,421 feet, Rand Airport is 5,483 feet, and so on. And on a map like this, you'll get a general idea of the average height of the ground level where you are flying. Just to continue with this example, if you're flying in Joburg, you will have an average height of, let's call it 5,500 feet above sea level. So the ground won't obviously change. Johannesburg is 5,500 feet above sea level, and that won't change. So if you're flying at 6,000 feet and the general altitude of Johannesburg is 5,500 feet above sea, then you can obviously make a little calculation to figure out that you are roughly 500 feet AGL, or above ground level. If the actual QNH today in this example at the bottom left is 1020 hectopascals, the pressure will obviously change from day to day, just about hour to hour, according to weather patterns. Now in this case, if the QNH is 1020, that's the starting point of figuring out the pressure, altitude, and various other things. Now if we start talking about pressure altitude, you have to understand that pressure altitude is measured from 1013 hectopascal. It's also called QNE, and when we talk about flight levels, we are talking about pressure altitude and being measured from 1013 hectopascal. So if we plot in 1013 hectopascal, 1013 hectopascal is less pressure than 1020, and we know the higher we go, the less the pressure becomes. So therefore in this example, 1013 QNE will fit in above the QNH of 1020. The next very important thing to remember is that converting between altitude and pressure, we use 30 feet per 1 hectopascal. In this scenario, we have 7 hectopascal difference between the QNH and the QNE. Those 7 hectopascals times 30 feet per 1 hectopascal brings us to 210 feet. Put in the 210 feet between the QNE and the QNH. Back to altitude, we've got 6,000 feet between the aircraft and the sea, but if we want to figure out our pressure altitude, Pressure altitude is measured from 1013. You are flying at a pressure altitude of 5,790 feet. So in the next problem, we have an example about an aircraft that's flying VFR in an easterly direction at flight level 075. Now this is obviously referring to the semicircular rule, which we will discuss in a later video. The QNH is 1024 and there is a ground obstacle at 6,230 feet. That's the little antenna on the right hand side. And the question is, by how much is the aircraft clearing the obstacle? So we'll start with filling in the information that we have. Right at the top, we are flying at flight level 075, which is basically 7,500 feet pressure altitude. Q and E we've plotted in as earlier, and in this example the QNH is 1024. The antenna is at 6,230 feet, and at the end of the day the question is, by how much will the aircraft be clearing the ground obstacle? The difference between the QNH 1024 and QNE 1013 is 11 hectopascals times 30 will give us 330 feet. Aircraft is flying at 7,500 feet pressure altitude. Pressure altitude, as always, is measured between the aircraft and 1013, the altitude above sea level, which will be the 7,500 feet that they've given us plus the 330 feet. Our altitude is 7,830 feet. Now we can determine our clearance of the obstacle. That 7,830 feet will be deducted from the 6,230, and at the end of the day the answer will be 1,600 feet. Another important aspect to remember is that Q and E will not always fall above the QNH. If, for example, there is a serious cold front moving through the country, the pressure will drop, and in this case you'll have to plot the QNE below QNH because the pressure is higher, and the same principles will apply between the QNE and the QNH, and therefore there's 90 feet. Pressure altitude of this particular aircraft will be the 6,000 feet altitude between aircraft and sea level, and if we're measuring between aircraft and QNE 1013, you'll have to add 90 feet in this case. So that is basic altimetry. I hope this little tutorial helped in laying the foundation. It should help with most of the problems that comes your way from CAA. If you have any other questions, helicopter specific, principles of flight, technical, please send them through, and we will hopefully get to more of these tutorials. Thank you for watching.